Okay, well, let's kick off. It's just gone 8 o'clock, so let's kick off the webinar itself. So I'm going to shut down the webcam here, and we can focus on the presentations that we've got. As I mentioned, we're going to be talking today about sort of using FME within the utilities and talking about some industry success stories that various people have put together. The agenda is pretty straightforward. We're going to do some brief introductions with our guests from Georgia Power. They're going to talk about some of the examples that and uses of FME that they have done in their organization. I'm going to follow up with a couple of examples from other users from around the world. Along the way, we'll have a couple of Q&A questions, and we'll also be running 1 or 2 polls depending on the time frame. So with us we've got Paul Schneider, Jeff Devet, and Renato Salvaglione. Good morning there, guys.
Yeah.
And myself, I'm Mark Stokes. So welcome everyone, and thanks a lot for attending our webinar this morning. And if you've got questions as we go, alongside us here, we've got Steve McCabe, who's one of our database specialists and actually very knowledgeable about Intergraph tools as well. So on your panels there, you can ask us a question. We'll try and answer them as we go. If we don't answer them, we will follow up. And just a reminder to everybody that the webinar is recorded, and at the end of today, at some point, you'll receive a follow-up email with the link to the recording and to the PowerPoint slides that make up this presentation if you want to pass that on to any colleagues that were not able to attend today. So we're talking about using the FME tools within the context of the utilities industry. What we do here at FME is help people connect with their data, transform their data, and if it is needed, use some automation using the FME server products. So what was interesting today was, or as I mentioned, putting together this webinar was just the broad range of data formats that people use within the utilities and the diversity of tasks. So we've got a kind of a theme of diversity and inclusion in our webinar today. Most of the people that we're going to be talking around are people working in the electric, gas, water and sewer distribution, and also some of the land-based users. I think they would find a lot of this material very relevant as well. So we're going to start off with a poll just to find out where people are coming from. This slide Stephanie chose because the person that we're working with today, Steve McCabe, he used to be a steel rigger, so that's not a picture of Steve, but that's what his former life was in the world. So I think that poll is probably close to closing, so there we go. And so we'll continue with the slides. So unfortunately, I don't see the poll results, so so I can't really tell that. Oh, okay. So most of us are from electric, but we've got quite a few from other. So if you are in the utilities, the other utility space or somewhere else, let us know. Okay, so just a quick look at some of the formats that we include in this utility space. All the major GIS formats, from Small World, Intergraph, Esri. I think the folks at Georgia Power are mostly Esri users for their GIS, and also working with AutoCAD Map 3D Enterprise, which I think is the new term for the AutoCAD Topo base. And a big part of FME in the past, and actually still going now, is migration from legacy formats. So Steve has helped quite a few people move from Intergraph Frame into newer GIS platforms. We actually helped here the city of Vancouver quite a number of years ago move out of Vision into their current Autodesk Enterprise products. So a wide range of formats on the GIS space used by the utilities users. And also really important in the utility space are the CAD formats. So that's a very common use case for utility users, is that round tripping from the GIS into CAD, coming back in from CAD into the GIS, coming from engineering drawings or something like that. We still do have trickling in, and actually just working with a group now who are still moving from a CAD-based, paper-based, drawing-based system that they use to manage their utilities to bring that into a more modern GIS. So that those migrations are still going on today. And then there are a wide range of sort of ancillary kind of formats that are used for data exchange. A lot of these around the real-time engineering tools that people have, the OMS and DMS systems. So there's a couple of standards out there, SIM XML and Multispeak, which are XML formats used by some organizations to move between the GIS and these OMS, DMS kind of systems. Some of those vendors of those products have built their own data standards. So CGI have a JSON-based interchange format. And we've also worked with other tools like PLS CAD using their XML reporting tools. So the PLS CAD is, I think, a kind of a transmission design tool set. And then this is just a list of the diversity of tasks that we've seen that people are using FME for. It's a wide range of applications that people have been able to use our products for. Real-time, GPS, mobile kind of work, and also any sensor data you can bring in. So that's one use. Data validation, mentioned GIS and CAD, round tripping, tying into external systems like asset management, and synchronizing across GIS databases, synchronizing between a GIS and sort of a public database, or sometimes synchronizing between your facilities GIS and a land-based GIS. They might be in different products as well. Okay, so that's enough kind of rambling on there about the general sort of utility space where FME is fitting in. Let's hand over to our three guest speakers at Georgia Power, and they can introduce themselves, and they will share with us some of their experience in the utility space at Georgia Power.
Great. Well, thanks, Mark. I really appreciate it. My name is Jeff DeWitt, and I am in our Economic Development Group here at Georgia Power. And we'll also have Paul Schneider, who's in our Maintenance and Reliability Group, who's going to be presenting, as well as Renato Salmian. He is in our Land Department. So you'll hopefully get a little bit of an overview of some of the different formats and scenarios that we use FME, and you'll probably see a lot of the variety that Mark was speaking about. So before I get into that, I'll just kind of give you a little overview of Georgia Power, the company. We are the largest subsidiary of Southern Company, which is a private investor-owned utility in the Southeast, and have about 8,500 employees, a little over 2.4 million customers as of now. And even though the map itself shows that we serve the majority of the state of Georgia, again, 155 out of 159 counties, we also compete and work with our other utilities, electric utilities, which are some of the local electric membership co-ops as well. So We work, again, pretty much everywhere throughout the state. All of our situations that we work here in their different departments, we deal with information and data from all over the state. So kind of getting back to a little bit what I do in economic development, I'm pretty much responsible for maintaining a lot of our databases that we use for some of our applications, specifically site selection tool that we use to market properties in the state is one of our primary ones. And some of the scenarios that I'll talk a little bit about, specifically in economic development, really have to do with kind of keeping that data up to date. And a lot of what I use that for really are not GIS related. We use a lot of text files and spreadsheets and some of those other quote-unquote flat files to keep our database up to date. So I'll go through some of those. And I really like to think of FME as kind of my go-to tool, that I really use that to try to automate a lot of the processes that otherwise would be a really manual or tedious process. So I will kind of use that as my default tool to go and try to solve some of these data challenges. So the first example I wanted to talk to you about is kind of dealing with one of these examples with text files. So this particular example, I'll be pulling in information for unemployment data, and we try to get that updated at least once a month. So I will go out to the U.S. Bureau of Labor Statistics website, and you can see an example of what that looks like down on the bottom of the screen. And it's basically just a text file. And what I've found is I've tried to find a way using FME to go through that text file, parse out the information that I need, and kind of combine that all together and update directly to my SDE database. So some of the things that I use to do that in this transformer in the workbench, are dealing with primarily with string searchers, and that's really key when you're working with text files, to pull out certain parts of the text line and just focus on very specific parts of each text line. And another thing that comes out of that is some of these lists. So I use a lot of list indexers or manipulating lists to really pull all that information together once you have these individual text lines separated out. So what's really important with this, and what I've found, is that the data itself has to be in a very standard format. So it has to be consistent throughout so that every text line kind of repeats itself. So that's one real key thing that you need to keep in mind. And another thing I kind of stumbled on, especially with text files alone, is the text line number is also really important. And I've kind of come up with a scenario where I'm joining some of the data that I pull apart, and I use that text line number. So basically that's the number of the line of text to try to piece some of that information back together so that I can update my SDE. So just a couple of scenarios to think through when you're working with text files, because you don't really get a lot of information directly in the format when you pull it in FME. You really need to start parsing it out to pull that information out. So another example we deal with in economic development is getting information from XML format. This particular example, I use this when we're updating kind of our office and industrial properties. And again, I mentioned our site selection web application. That is a critical component to that, because these are the actual properties that we will market to anybody looking to move or relocate to the state. So it's really critical that that information is updated on a very consistent basis. So we get the XML data from a couple different third-party sources, and I'm kind of old school when I talk to some of the guys now. There's some easier ways to manipulate text files, or excuse me, XML files. But the way that I've initially started with this was to use a XML mapping document, a .xmp file, which really is just a way of mapping out the XML file to put on your titles and your headers for all of your attributes. So I think that there is an easier way to do that now, but I haven't gone back and tried to update that because this has worked out pretty well for me. So what happens after I pull in the XML file? I do a lot of different other transformers to manipulate the data. I do some things like the update detector is a key transformer that I use, and that really is used for comparing what I get in the XML file back to my original master SDE database. So I will determine from the XML files what files have been added, updated, or deleted so that I can parse that information out into my database accordingly. So another thing that I use a lot, and this gets into some of the core GIS functionality, is the nearest neighbor. We use that a lot to identify features that are within each of those property records, and that's stuff like nearest interstate or nearest airport or any of those other types of facilities. So, and all of that is done, and then at the end of the day, it writes out back to SDE in a version database. So I have a version set up in that workbench so that it'll write directly to that version. To fully automate the process, I could actually post and reconcile that version directly and write in FME so that it can literally just be a one-click solution. So that's been extraordinarily valuable, and I run that one all the time. So that's been a huge time saver for that. One last example I want to touch on has to do with keeping some of our information up to date. So once we have some of these properties in our database, what I will go through is a process that we send out information of what we have to our contacts who are responsible for this information. And I use an example here where I'm pulling the data directly from SDE and go throughout a process where I filter out some of that information to showcase only specific counties or specific regions. And then I parse all of that out and write it to an XML templator, which is a great way to really format your HTML so that you get a really nice document or a nice format to send out in your email. So instead of just having regular text, you can use that XML templator to write it into a nice HTML format for the email. And the actual transformer that I use to write out the email is, I think, a custom one that is the HTML Python emailer. And again, you can see a snapshot of what that transformer does. And again, all of that information in terms of who the email goes to, what the content of the email, and who the recipient of the email, all of that is done and pulled in from attributes that are generated within the workbench itself. So again, some of the key things you have to have is obviously the contacts in your data, some of the other information that you can actually pull together and manipulate in FME. You can write that out as a result, which you can see an example in that screenshot as well. And then you can also see kind of the output of what that email looks like. And again, a nice HTML format. We had a link for the image of that property that we included. So it makes it a really nice package that we send out to the contact. And how this helps us is it is an automated way that we can send out this information so that they can easily get it, consume it, and reply directly back to us with the information. So we send this out for over 800 properties, and this has helped us to keep our information up to date, which is, again, very, very critical. One thing I didn't mention is I've also have another script that takes that email, parses that back out, so it will actually then write directly to SDE. So a lot of great tools you can manipulate with that FME HTML Python emailer. So I've really found that to be useful, and we've gotten a lot of great use out of that. So I'm going to turn this over to Paul Schneider. He is in our transmission maintenance and reliability group, and he's going to talk to you about some of the transformers that or some of the workbenches and FME that he uses in his organization.
Thanks, Jeff. So my name is Paul Schneider. In transmission, we have a regular occurrence where we need to find switches and substations across the Southern Company territory. And to be able to create those files, what I've done is used FME to basically take our data from SDE, extract it, and format it in just a way to create POI files that can then be loaded into our Garmin GPS units so that our folks can efficiently get out to the stuff in the field. It runs as a scheduled task every week, and so I set this up probably about 5 years ago and have never touched it since, and it's been a workhorse and very helpful to our folks in the field. The next one I am showing you guys is the GRSS. The great thing about this one was I knew nothing about how to make this. I went on to the FME website and was able to find a GRSS example. I took their example and just customized it to meet my needs. So what this does is we'll take what we call APTIS, or an abnormal situation, and takes that data from our GIS, extracts it, and creates a GRSS feed. The cool thing about GRSS is it allows our folks to subscribe to it, and then they'll get notifications of any time anything's changed within that RSS feed. The other cool thing about it is it can also be loaded into a map, and you can spatially view that XML, GRSS XML on the map, and click to identify all those features across the map. We constantly get ad hoc requests to create basically any data to any format to another format. It's a common request. Typically, we'll take GIS data from ESRI format and convert it to a KMZ for display in Google. Some folks like to have that on their mobile devices or use it in Google Earth. We've also used it for DEM conversions to create contour lines. And I initially started out, my background is GIS, and I'm very accustomed to ESRI software, and that's where I generally start. So I initially tried to convert the DEMs in ArcMap, but it couldn't handle it, and it kept on crashing on me, unfortunately. So I went to FME to see if it could handle it there, and I don't know how exactly FME has it set up, but it was able to churn through that data without crashing and get the result I needed. One of the more recent applications was some folks in the field are using iPads, and they found an app called Form Connect, and it allows them to basically create a form that works completely disconnected. And that was one step of the process. It allowed them to basically get away from using paper and use all digital format. But that data, then you need to get it back into the database one way or another. So the application allows for easy export to CSV or XML. And basically what I did is I created a workbench that would manipulate that data and load it into a database. And I gave it to a couple key people, and they essentially receive all those forms from the field. We'll take that data, and then using the quick translator, just point to where that CSV is and import it straight into the database, making sure that we don't have consistent data and quality every time. So that's about all I have, and next will be Renato Salvion. He's in the land department.
All right, thanks, Paul. As Paul mentioned, that there are a lot of ad hoc data conversions that we have, and that's no different than we have in land department. What we think we're going to see FME is headed for our usage is as we identify more use cases that are repeatable to the users and identify tasks or workflows that we can simplify such that we can push our users, we can push FME for our users, and the role of the GIS analyst is basically just build them and maintain these tools. So I'll pick up one use case that we have in land department, and it's called environmental best practices for transmission construction projects. Until recent changes from the Georgia DNR, every transmission construction project in the state of Georgia requires an erosion and sediment control plan. Other states call this best practices, or BMPs. So the land department, my department, with coordination with our transmission construction and design organization, is responsible for submitting these plans to the DNR. So this is, in a sense, the workflow of how we've done best practices for this particular data or workflow. As part of the process, environmental specialists are responsible to provide the surveys to identify different features in the area, including the wetlands, buffers, protected species, and other environmental features that needs to be incorporated to the plan. Vendors are hired to conduct surveys, and upon completion of field survey, GIS data is submitted to the specialist, who then does the QC. Specialists also load the vendor's submittals to our GIS database, or the SDE. After identifying GIS features that needs to go to the plan, the specialist informs the GIS analyst to convert the GIS from SDE to a DXF format. The GIS analyst submits the DXF back to the environmental specialist for another round of QC. After the final QC, the DXF is then submitted back to the land department to our mapper, who incorporates the environmental data to the plan, which is then used by the engineer to finish his design. In this workflow, there are many handoffs and repetitive QCs of the same data, which gives a lot of potentials for issues. But hopefully, there's enough QC done that we get through the right data to the mapper or the engineer who needs it. So here, next slide, FME enters into the picture. And some efficiencies were added into the process by giving the environmental specialist a workbench file to basically load the data and create an Excel report, which is on the upper right side of the slide. On the lower left side is another workbench file for the GIS analyst to do his thing to basically create the DXF file. So there were more efficiencies to do their tasks. It became quicker, but the hands-off did not change. It just made the task easier. So in the next slide, in order to streamline the handoff, it was decided to remove the GIS analyst as the middleman to the process and let the initial and final QA stay with the environmental specialist. Also, the two workbenches used by the environmentalist and the GIS analyst were combined into one workbench that the environmental specialist will use. The GIS analyst was tasked with the support and the use of the tool, and also ensure that the data load in the SD has been processed correctly to accord with GIS standards. So what used to be a work process is now being done through a simplified automated task. With the changes, a single task was left for the environmental specialist. After QC of the vendor submittal from an ArcMap map document, the environmental specialist is now ready to crank FME. The workbench produces an Excel spreadsheet that has been delivered of all the data that's been delivered for the specialist to use as a reference, or again for QC as well. A DXF with standard labels and a data load to the SDE. The environmental specialists were happy with the process. However, more improvements need to be needed. If you look at this slide, you can really tell that this vendor submittal this process or this task could actually be applied to any workflow that requires a vendor submittal where data is being delivered in a GIS format into other derivative products. And there is a lot of this type of task in a department, whether it's data being created, started off from a researcher, handed off to a location engineer, or from a surveyor to a CAD mapper. So we see this common repetitive task that we know that we can we can put into FME and then pass that tool to an end user. So for the remaining tasks, we saw it's repetitive and it made it easy for the user to rerun the tool with just a few parameter changes. However, there's always a possibility of duplicating the data load into the SDE or a need to rerun the project. For the Excel and DXF, it's okay to overwrite the files, but this is not the case for the SDE. We could teach the environmental specialist how to disable or enable the writers, but that's not efficient. So we're adding a matcher, a tester, and a Python email notifier into the workbench. This is still in development, but I think we're getting progress with the idea of trying to prevent duplicate data loads for every project or if there's a need to rerun the project, we need to find a way to inform the user that the data is already in the GIS database. Also, we know how difficult it is to receive or to collect field data, especially when you're collecting polygons, and typically we know the geometry will not be perfect all the time. So adding a geometry validator transformer into the workbench to add additional QC data would probably be a good thing to add, or a good improvement to this tool. So on this slide, you will see the two transformers that we're testing. The matcher transformer, which matches certain attributes that's configured, as well as geometry. So this transformer will determine if data has been duplicated, and if it's duplicated, then it'll just send an email to the user that, hey, you need to review the data, make sure you're not duplicating the data. So, and that information is being passed through the email notifier that comes out of that failed features coming out of the transformer. And maybe I can use some of Jeff's Python HTML, XML formatter to put maybe a picture or some data into this email. Lastly, using the symboler and the labeler transformers that comes out of the box from FME are not the best renderers for CAD, but it is decent enough. However, the output still requires manipulation by the mapper, and this also takes time. We bought a couple of map text labeler licenses to FME and now added the map text labeler transformer into the workbench. You can see the difference between the FME labeler styler and map text labeler output on the right. We got better quality CAD outputs with this new extension, so really a good helper. If you look at the pop-up for map text labeler, and if you've been using an S3 tool or any GIS software for a while, you would see how easy it is for someone writing the workbench to configure labels as well as symbols for a particular project, and this works with any, it outputs out most of the popular CAD formats. So to finish, that's how that workbench is going to look like when we've added QC, we've added that map text labeler, and hopefully we can basically use this workbench file to other tasks that have similar use cases as well. All right.
So Mark, hopefully that was a good overview for everybody that showed a lot of the sort of different scenarios that we use FME for. And again, I just really want to stress and follow up a little bit what Paul and Renato said. These are just a handful of examples, but we use this a lot. I would say kind of a lot of throwaways, which are just a quick overview or a quick transformer. You need something from this format to that format, and it literally just takes about 5-10 minutes to pull that information together. We use that FME all the time. That is not a quote-unquote standard one, but it's just a quick 5-10 minute transformation that we can write out to just about any format. So we use that a lot.
That's great. That is a wide range of uses. You've got.
If I may add, where we're headed with our the tools that I mentioned.
Yeah. Okay. Yeah, that's a wide range of use, from business data to emailing, GIS, CAD. We've got a couple of minutes for some questions. So somebody was asking, are you using the FME server there at all in your organization to do some of this work, to automate some of these workflows?
Yes, Mark. So so that's kind of work we're headed with this tool that I just presented. We did just purchase FME server. We're up to the point where we're trying to incorporate that into our infrastructure next, so that some of the vendor submittals that are available on our network shares can be accessed to server. So that is the next step. Is we are getting to move this to the server.
Yeah. Okay, that's good. I'll just take back the slides here. Okay. Yeah, and I think we've got some other couple of quick questions that we could probably get through. Somebody was asking, are the green transformers custom? I think you've got the HTML Python emailer there. Is that a transformer you downloaded from the FME store?
Yeah, that is a custom one that I found, I believe. That was an easy download. And the other one I also used, which was custom, was the update detector, which has been invaluable, an easy way to find adds, deletes, and updates.
Yeah, great. And somebody was asking, what was this, Jeff? You were reading in a lot of XML source data. What systems are generating that XML?
This primarily came from third-party vendors. They were sharing their property information in XML format. I'm not sure why they chose that particular format. That's just kind of what that was the option that we were provided with in order to get that data. So what we did was actually, when I first started this process, I was actually downloading the XML file to my local machine and then running that way. But now I'm connecting directly to either the HTML page that has the XML or even an FTP site that has the XML file. So I bypass that directly and are going to the source file directly.
Okay, great. I think we've got as we're doing QA, we can run a quick poll just to see in the audience who is still using FME or who's new to the product. Going back to using FME Server, so FME Server does allow you to do some of that emailing rather than sort of embedding it into the actual workflow there. It's part of the FME Server upload, so you could use some of the notifications tools in FME Server when if you ever go that route. Somebody was also asking why it looked like you were writing out to DXF rather than DWG files. Was that just because that's more widely read by some people? I think that was you, Renato.
Yeah, that was the requirement for our mapper. So we don't know anything about CAD. GS analysts don't know anything about CAD. We just followed the requirement that was given to us. So that we were told that that's the best format. That's the format that they want.
Yeah. Yeah.
But
the good thing in FME is that all you have to do is change the file ending, and we'll write out DXF or DWG depending on what.
Right, and it's used the same transformer.
Yeah. Okay, so let's keep going. We've got a couple of. Thank you very much, guys. That was very interesting. Thanks for putting together those presentations. It's a lot of effort. Gives a really good perspective of what one organization is doing. We've got a couple of other quick overviews of what other people have been doing that we've stolen from some of the world tours that we do and other events. We just had a user conference, so one of these is from our recent user conference. So the first one I was just going to talk about is from Atmos Energy. This was presented at one of our World Tour events last year, and I've probably butchered it a little bit to squeeze it into the time frame that we have, so I've included the full link to the presentation in these slides. When you get these slide decks, you'll be able to trace it back to the full presentation. So this is a sort of a CAD to GIS migration that they did to load up their GIS system. And so the problem here was to migrate from a drawing-based CAD platform to a fully fledged GIS. They had decided to go with GE Small World GIS. And these are always interesting problems because the CAD's data is usually just a drawing. Any information that you have in the drawing is usually just text. You can see some of those have been highlighted there. The existing info is just some text that tells you what kind of pipe that's associated with. I don't know whether you can see it on your screens, but in here as well, they've got some lot lines, and the lot numbers are inside those lot lines, and so They want to try and get the lot numbers associated with the land-based properties. And so their goal was to try and transfer the CAD data to the GIS, maintaining as much of the information that the CAD drawing did have, and minimize the data loss, and of course reduce the amount of effort that they had to do in cleaning up the data once it got into the GIS itself. So they had put together quite a nice workspace, and it's a very nice clean workspace. They've shared that with us, so I can open that up here if hopefully if it's, yep, there we go. So this is one of the workspaces that they were using. You can see it's got quite a large number of feature or layers coming out of the CAD data. It looks nice and clean because they have used a custom transformer to bury a lot of the detailed work that they do in here. So let's have a look at one of these custom transformers, and you can see that's a little bit more complex. So for each of these different types of entity that they're loading in, we're looking at the lot lines. They've got quite a lot of detail going on, and this is mostly around cleaning up the data that they're bringing in from the CAD data set. So they've got a chunk here that is pulling together the lot lines and making a lot area out of them. So they're doing some self-intersection cleanup, intersecting lines to make sure they're nicely noded, making sure all the line ends snap together using the snapper transformer, and then using the area builder to build the lot areas. And then on top of that, they've got a tool here called the point on area overlayer. So what they're taking is these areas that they've built, which are now the lot areas, so that's kind of like the cadastre data, bringing in the text features, which are the point features here. And so now what they could do is they can get the lot numbers associated with those lot properties. And so each of the different custom transformers that they have in this workflow does some sort of cleanup work like that. So it's quite a lot of detailed work, but by the time it gets into their GIS system, the data is a lot cleaner. They do a visual inspection, obviously, in the small GIS that they've loaded the data in, and they also have a detailed look through the actual editor window of the Small World GIS to make sure that everything went in correctly, and they can have a look at any attributes that they were able to populate from that CAD load. So that's a very typical task of a CAD to GIS kind of data migration, thanks to Marcin for sharing that story. They've moved on from that now, so now that they've gone into the GIS, they can have the process working in the other way, which is kind of what Renato was referring to. So now they're taking that GIS data that they've loaded and exporting it out to CAD for some of their engineering users. That's a bit of a story for another day, but that's a very typical CAD to GIS kind of migration story. Our next summary is from Larry Weeb at Manitoba Hydro. So this was done at, again, one of our World Tour events, this one in Winnipeg last year. And this is more of a kind of a data analytics, business intelligence, location intelligence kind of problem rather than a traditional GIS problem you might think of. And so in their case there, what they wanted to do was to create a system to respond to kind of disruptive events that might affect their network, the reliability of their network, and the safety of some of their equipment. So that involved pulling together a disparate set of data, get rid of paper maps and replace that with more online maps, and also for the critical data to make sure that the best data was available, and more importantly for them in terms of this particular project was to make sure that data was up to date. And this project was a fire proximity awareness thing in the Manitoba area. So a lot of forest fires up in there, broad expanses of northern Manitoba. And so what they want to do is produce daily fire maps that show what the status of any forest fires or other events are, and keep track of that. So they had to pull these fire maps from an FTP site. Somebody else is keeping track of the location of these forest fires, define what equipment or parts of their network really needed to be highlighted on these maps, add in some real-time weather, because in the fire season, the kind of weather that you have really is a predictor of how serious the fire is going to get. And then the final result is to create a set of clear, clean online maps with appropriate symbology so that people can see where the fire locations are and where that is relative to their infrastructure. So this is the kind of maps that they're producing. So this is one of the weather maps that they're creating from their displays. And you can see the arrows there showing the wind conditions that they're pulling down from a feed. That's every 15 minutes. They get a new wind and temperature updates from their maps, and those obviously people can zoom in on that, and you can see for local areas what the weather conditions are like. They also bring in a lot of supporting data. Some of that is coming from a WMS feed. I think that must be coming from NOAA. They refer to these MODIS hotspots. And so MODIS is a satellite feed that is used for, I think it stands for moderate resolution imaging and spectroradiometers. So that's a satellite that actually does keep track of things like forest fires. So that's where some of the data is coming from. And they're also merging that with other information from the RCMP, which shows where fuel locations are and other base map information. On top of that, they're also keeping track of the crew locations. So the map on the right there is where the fire crew locations are, so they know where their resources are and what they, if they looks like they're going to be short of crews, where they need to add more fire crews and maybe use some of their own resources. And then they also have a system for actually tracking the crews and taking the points of the crew locations, bringing those into lines and producing tracks of where the crews are working so that they can keep those crew locations up to date. That data is collected every 15 minutes as well. So there's a lot of, every 5 minutes. So there's a lot of data being pulled together with their various workspaces that are being used to pull that together. So that's kind of a more of a location intelligence kind of process that Manitoba, very cool, I think, process that they've put together for watching their infrastructure and looking for hazards on their data set. So consolidating a very diverse range of data sets, bringing together the appropriate transformations to simplify the data so that people can see really clear maps online in a suitable format for presentation and display. So thanks again to Larry for sharing that, one of our world tours. And then the last one, again, just to show the kind of the breadth of areas that people are using FME in, a bit closer to home here in northern Washington and Montana. We're just across the border there. Erica Jacobs was using FME to do some network tracing work on some of their gas networks. So this is kind of an interesting application for FME because FME doesn't really have a logical network model when you load the data in. And so any network work you do is really based on a physical model, as it were, where you're using spatial relationships to determine the connectivity of the feature. So when you're doing that kind of model, your data has to be squeaky clean. So a large part of Erica's job was to make sure the data was clean and then have a look at some of the transformers that she was using. And so the main focus of her workflow was to find any of the customers that are downstream of a particular gas fitting that they wanted to do some service work on. And the core transformer here is the network topology calculator. We can have a quick look at that transformer. It's very simple to look at, and I've got some data that I've got from the City of Vancouver, some transmission mains data. And so the network topology calculator actually is a very handy tool if you want to validate your own network and see whether it's hanging together in a nice clean way. So I'll just quickly run that. It's reading an AutoCAD file. So this would be typical if you were loading data in from AutoCAD into your GIS and you wanted to make sure, see how clean the connectivity of certain features are. So we're loading in the transmission data. I'm using the network topology calculator. So what that does is it takes all the line work and sees if it can hook it together. And then for each of the networks that it builds, so if there's a bit of a disconnected network, that will build a separate network. It'll generate a network ID. So all the features that have some sort of level of connectivity and joined together will get the same network ID. And then in my case here, what I'm doing is I'm aggregating together all the features with the same ID. So if I have a nice clean network, what I'll get is a single honking great big feature which has a single network ID. So what we can do is go over and look at the data inspector. I'm just throwing this information up into the data inspector. So here we are in the beautiful city of Vancouver. These are all the different network IDs that we've generated here. And so if I click on that, we can possibly see that one of these features is highlighted over there, and you can start to click through the different parts of that network, and you can see that that's just a very small part of the network. And if you click on another entity here, it'll jump to another part of the network, and we can see where that is. And so you can see here that in this particular case, the network isn't very cohesive and is not joined together. So this is particularly well. So this is the bulk of the network here. I don't know whether you can see that when I click on it. That's the main network, and all the rest is somewhat disconnected. And so we probably need to then go in with some of the tools in FME like the snapper or self-intersector to start cleaning up the data. And you can see here, if I zoom right in there, a gap in between there. So that needs to be cleaned up if we wanted this gas network to be a nice uniform network in that particular case. So that's using the network topology calculator. So the tools that she used to clean up her network were to do some filtering, to filter out the particular parts of the network, use the spatial filter to figure out which components are connected to each other. Use the geometry validator. Renato was mentioning that he's thinking of using that in some of his work. So the geometry validator can look at individual geometries and look for whether they self-intersect and that kind of things. A very big part of the FME networks is that FME doesn't support complex edges, so you have to split out the complex edges if you have them coming out of Small World or your Esri geodatabase. Then she's using the network topology calculator to create the individual little networks, using the point on area overlayer to find out which meters and which T's sit on which piece of the network, and then using the feature merger to join together data from different sources. And so her end result here is a set of networks which highlights the junction that they're going to be working on and all the meters that are downstream of that junction in nice clear maps. There's a couple of different maps here, so she can throw in a whole bunch of areas that they're going to work on, all these junctions or parts of the network pipe that they're going to work on, and then they can see which meters will be affected by that. So some very cool work in a kind of a network-oriented way, which a lot of people haven't really used FME for. And so I think she said that she's going to carry on and do a whole other bunch of work in this kind of area, finding the number of meters served by each gas pressure zone, find shutoff islands within her network, do some network health checks, and look for any isolated steel pipe that might be sitting around and generate appropriate maps of all that kind of stuff. So Erica's doing some very cool network-oriented stuff with FME. So that's that presentation Erica put together actually for our user conference, which was here in Vancouver in last June, where we had a large number of people join us in Vancouver to get excited about FME. So thanks to Erica for putting together that presentation. We've got some time for a little bit of Q&A. I haven't been watching the questions here, so maybe we'll have a quick look here to see if anybody's been asking any other questions as we go. Nope, it's been a little bit quiet there, and we're starting to run out of time, so we'll just keep going. We have quite a few other great presentations by people in the utilities arena. So within this slide deck, we will include the links for those other presentations. And I did mention that the presentations that we've done are all online in their full forms. So we'll have the links to those in the slide deck. And you'll get an email with the link to the slide deck after this webinar. So you will be able to go and explore what other people have been doing with FME in the time frame there. So we have had somebody just throw in a question there. What's the difference between the FME network trace and the Esri network trace? Well, I think the Esri network trace will be more of a logical network trace, whereas FME is purely a physical trace. So what we do is basically a spatial match. Does this line physically connect to another line? Does this meter or junction physically connect to that one? Whereas the Esri network traces, they build up the IDs of this line goes from here to here. This junction is connected to this end of this line ID and so on. So they all have those network IDs that Esri uses. So there is quite a big difference between the network tracing on a logical network and what FME does, which is more of a physical spatial kind of network. Okay, well, I think that's the end of our hour this morning. So a bit of a different webinar this morning, and a wide range of applications and looking at different ways people have used FME in this utilities context. I wanted to say a special thanks to Jeff, Renato, and Paul for taking the time out of their schedules. Are they still online? Thanks a lot, gentlemen.
Yeah, you're welcome. Glad we could input and showcase a little bit of how we're using FME here.
Yeah, and they said it was okay to throw up their email addresses there, so if you have any direct questions for them, we can, I'm sure they will be happy to answer them. I'm Mark Stokes, so you can contact me if you've got any other questions about FME in general or some of the presentations that we did. And as I mentioned, you will get a follow-up email with the links to these presentations. If you wanted any other information specifically about those presentations, you can contact me and I can try and get you any workflows or other bits and pieces that the authors of those presentations might want to share. So with that, it's goodbye from me and goodbye from Jeff, Renato, and Paul. Thanks everybody for attending, and hopefully you'll join us at our next webinar here at Safe Software. Thanks a lot.